Hello everyone. In this video we will discuss about AC to DC rectifier, single phase, half wave, uncontrolled rectifier, and our load is a resistor and inductor. Okay, this resistor and this is inductor. They will become our load. So outcome of this video, hopefully everyone uh, can describe how the waveform of each component of waveform of resistor, waveform of inductor, and also waveform of the diode. And also the second outcome is we will derive the important equation parameters of the rectifier, especially V out, important parameter of rectifier. Okay. Okay. First we have to erase parameter. Okay, this is the input part of the DC. This is the output. AC part here, DC here. Output is our DC. DC is our output. So input is sine wave. Input sine wave. Output will be pulsating input. DC. DC pulsating. Okay. This between this our output between terminal resistor and inductor. Okay. Our input is sine wave. We have positive cycle and negative cycle. Positive cycle and negative cycle. Okay. This one is positive cycle. This one is negative cycle, our input. Okay. Derive. Okay, let's start to derive the to look at the response. We have 0 pi. From 0 to pi during positive cycle. Okay, positive cycle. During positive cycle from 0 to pi. 0 pi. So maximum like this. V max. Positive will be here. The polarity like this. So we just follow the polarity like this, same as our input. So the current will flow from positive terminal. Okay, current will flow from this terminal, and then okay, look at our diode. Okay, arrow diode, same arrow with the flow of current. Okay, means that this diode will be forward bias due to same arrow. This arrow of current and arrow of diode same. So forward bias. So we know that for forward bias, diode will be short circuit here. Diode short circuit. So when diode short circuit, it allows current to flow. So a current can flow from positive terminal, pass the diode, and go through the resistor, and go through the inductor, and go back to source. So when the current flow through inductor, through the resistor, there will be developed voltage at resistor, we call VR. And also developed voltage at inductor, we call VL. VL is equal to, okay, inductor, we know that the characteristics of inductor is store energy. So it can charging and discharging. So VL equal to L di over dt. We already derived in the previous video. So for resistor at voltage across the resistor, we call VR equal to I times R. Okay. Okay. The output power is between this cycle. Okay, V out. This is V out. Okay, we know that our diode is short circuit. So means that the diode will be 0 volt. Short circuit 0 volt. So our input is sine wave, Vm sine omega t. Then there's this diode 0 volt, so means that there is no voltage drop at diode. So all the input go to output. So means that all the input voltage go to output. So our waveform of the output is exactly same as the input waveform between 0 to pi. Okay, due to our diode is 0 volt, so there's no drop at the diode. All the output is same as the input. Okay, this is the output from. So we consider from 0 to pi. Diode forward bias, short circuit. So V out will be equal to V source equal to Vm sine omega t. Okay, the one is between 0 to pi. So about the current, we already learned about the current in the previous video. We know that, sorry, not current, inductor. About inductor, we already learned in the previous video that inductor, the characteristic of inductor, it can store energy. So the inductor will be charging. Okay, during it receive current. When it receive current, it will charge. Then after it disconnect the current, the inductor will be discharged. Okay, the energy will be discharged in term of current. It will become current source. So means that after pi, we disconnect the current, we disconnect the voltage source. So the voltage source will be alternate from positive to negative. So we will change the direction of current, okay, from pi to, so let's say we assume this one is beta, okay. Okay, before that look at the graph of the diode. So from 0 to pi, diode will be switch on. So when diode switch on, the voltage of diode will be 0 volt from 0 to pi, due to diode is forward bias. So by short circuit, so 0 volt. So discharging from 0 to pi, our this inductor will be charging due to it receive current from the water source. So it will discharge. It will charging. It will charging until from 0 to pi. Okay. After pi to beta. Okay, pi to beta. Okay. From pi to beta, what happen is sorry. Okay, I have to delete it first. Okay, from pi to beta, okay, at this point, oh, sorry, let me change the color. Okay, we use green color. Okay, so from pi to beta, waveform will be changed to negative cycle. From pi to 2 pi, negative cycle. So first we analyze from pi to beta. So from pi to beta is negative cycle. Waveform negative cycle will be like this. Negative cycle, negative Vmax. So polarity will be go down like this, same polarity. So minus, plus. Okay, we know that during positive cycle, this inductor will become during positive cycle, this inductor is charging. Our inductor is charging. Then during negative cycle, when we alternate the voltage source, So there is no current flow. This voltage will become current source. IS, current source. So it will supply current to the source and also to the diode and also to resistor. So when current flow to this resistor will dissipate of energy, dissipate of power. Okay, I. So we know that current, arrow of current like this. So arrow of diode like this. So the diode will be forward bias, same arrow. Forward bias means that short circuit, means that 0 volt. Okay, short circuit here. Okay, short circuit. Okay, from pi to beta, diode short circuit. Due to forward bias. So from pi to beta, short circuit, so 0 volt here. Diode short circuit due to forward bias. Due to same arrow of discharging current from inductor. Okay. Okay. For this inductor will discharging the current, and you store here. It will discharge the current to all the circuit, and it will dissipate it from at the resistor, and until beta it will empty. Okay, dissipated current here, so it will be empty at beta. So discharging process here, discharging. Okay, this one is at beta it will empty. So due to diode is open a short circuit 0 volt means that all the input will go to output. So output will be same as the input. So output will like this. Input like this. So output will be same as the input. Okay, why? There's no voltage drop at resistor at diode. Diode 0 volt. So output will be same as the input like this until beta. Okay, however, at beta, this diode, our current source, this current source will be empty. So this current source empty, then there's no current flow from diode. From inductor. From inductor will be no current flow. So means that our diode is become forward bias. Okay, this current will flow from here. The water source supply current from positive terminal go to this inductor. However, we can see that arrow of this current and arrow of diode opposite. So what happened? So when this diode and flow of current is opposite, this diode will become reverse bias. Reverse bias, diode will be open. When that open, current cannot flow. Okay, now is from beta, to pi, from beta to pi, the current is 0. Okay, the voltage, this open circuit here. When the open circuit here, this current cannot flow, means that I equal to 0 ampere. Due to open circuit, current cannot flow. When current cannot flow, output will be 0. This output will be 0. I times R 0 times R equal to 0 volt. Okay. I0 current 0. So that means our voltage, our output voltage will be go to 0. Drop to 0 after beta. Beta until 2 pi. Okay, we save the input like this. So this our output 0. However, diode, okay, what happened to diode? We know that this diode is open circuit. Open circuit. When diode open circuit means that the voltage of the diode will be equal to the input voltage. Okay, voltage of the diode will be same as the input voltage. Okay, we know that this input like this, waveform like this. So the diode will be same as the input waveform. Just follow input waveform until 2 pi. Okay, after 2 pi, we know this one is the second cycle. This one is first complete one cycle. So after 2 pi, second cycle, the input positive cycle, so it will repeat same as the first half. This one. Okay, it will repeat again. So our output will be same as the previous one. Like this. Go short. Okay, same as first cycle. That one is during pi to beta, beta to pi. Diode open circuit. V out will be equal to 0 volt. V diode same as V source. Okay, current will be 0 due to open circuit. Okay, this one is okay. Now we have finished about the waveform. So now we go to derivation of equation. Okay, let's delete first. Now we continue with derivation of related equation. Okay, V out. This one is V out. This our V out voltage will be like this. Okay, from 0 to beta, and then we repeat again until 0 to beta. After that, we will repeat again. Okay, it's 2 pi. From beta to 2 pi is 0 volt. So our output V out average will be area over times. So from 0 to pi, from 0 to pi equal to, so we integrate this area, okay, this area and this area. So this area is from 0 to beta, Vm sine omega t d omega t. Okay. So what we get is Vm will be equal to 1 over 2 pi Vm, we can take out Vm, so Vm over 2 pi 1 minus cos beta. This is our average voltage. I average equal to, okay, average voltage is here, so average voltage will be equal to I is here divided by resistor. V average divided by resistor R due to voltage at VL is equal to 0. Okay, so average voltage will be average over R. So next is conduction angle. So conduction angle is gamma equal to So we refer to diode graph. So at what time, which angle diode graph will be conduct? Okay, it will conduct from 0 to beta. Okay, it will on here from here to beta. So conduction angle equal to beta, and then the extinction angle is beta. Beta is extinction angle is we refer to the current graph waveform. So waveform of the graph waveform will be current will flow from 0 until beta. So after beta it will 0. So it will come beta. Okay. Okay. I think that's all for our AC to DC rectifier. We're using uncontrolled rectifier. This is with diode. Based on load is resistor and inductor load. Okay, hopefully everyone can understand how to the waveform and also the related equation. Understand how to derive the equation and also draw the waveform of each waveform of diode, waveform of resistor, waveform of inductor, waveform of current. Okay, this input, output, the current, diode. Okay, that's all. Thank you. Bye bye.